now you try problem, take a minute to read the question on your own and attempt this problem first before you continue the video. Whenever you're done with your attempt, you can continue the video and look at the solution steps. In order to solve this problem, we again have a scenario for the revenue, and the revenue is being modeled by this quadratic function r of p, p being the basically the independent variable over here, the price, and r being the revenue we have. And basically, if we think about the scenario that's being modeled, you can think about as the price go up, we would have different amount of money going in. So remember, the difference for revenue versus profit is revenue is just directly how much money you're taking in. And initially, as you raise a price, you'll be able to take in more money, but as you charge more and more for one single item, you might not be able to sell as much, and therefore the amount of money you take in will decrease. So you might actually end up having less money overall, even if you are selling for more for one individual item. So that's the scenario we're thinking about. And with the graph, we want to first start with GeoGebra and plotting the graph first. And if we look at the function, we have r of p is equal to negative 120 p squared. And then we also have plus 750p. And this is going to be our graph over here. Once we look at the graph, you can see it's pretty hard to get the entire image in the window, and that's where we'll have to adjust the window to show the entire graph. And to do this, what we can do is in the upper right corner, you have this little gear that says Preferences. If you click on it, there is a pull-down menu showing up, and we want to change the graphics in order to change the window. And if we think about what values we want to include for the x-axis and y-axis, the dimensions is where we want to adjust things. Make sure this is unlocked so the system will automatically adjust everything based on your setup for the minimum and maximum values. And for our graph, before we adjust everything, we can see the x values are okay. We can see all the key features as to where the function touches x-axis, but the problem is on the y-axis. If you want, you can zoom out a little bit just to give a rough idea as to how high y value would need to go. And you can see as we're zooming out, this goes pretty high up, and it easily goes into hundreds. So just to give us a perspective and find a starting point, what I'm going to do is to change the graphics so the y value starts from 0. Because remember, our y value represents a revenue, and it's the amount of money you take in. So we don't really want to look at the negative values per se. And I'm just going to set the y value, the minimum, to be 0 so that I can still see the intersections for the y-axis. But for the maximum value, you can see if it automatically adjusts to 873, it's still not big enough. So I'm going to do 1000 just to test out. And you can see as we do this, it's still not big enough. Meanwhile, if you look at the x value, it's showing a very large range of x value that we don't really need to see. So I want to adjust the x values as well. X value representing the price, again, I don't need to see the negative x values directly, so I'm going to start from 0 and see what happens in terms of the window. Similarly, for the maximum value, I can just go to 10 because I saw before the x value was good enough. And once I do this, you can see we're getting closer to seeing an actual shape of the parabola. And now if you move this around a little bit, you'll actually be able to see where the turning point, the vertex of our parabola is going to be. So that's where I'm going to kind of focus on. But notice now I can't really see the bottom of my graph anymore. I can't really see where the x-intercepts are. And if you look at the dimensions, you'll see the y value doesn't include the value 0 anymore. And that essentially becomes somewhat of a problem for us to not see the intercepts over here. So just do a little bit minor adjustment from here. You should be able to see the entire graph with all the intercepts, both x and y intercepts in this case. So once we have this graph, feel free to zoom in and out a little bit just so you can feel comfortable with seeing all the key features in this process. But this adjustment of the window will be really helpful for us to find all the important answers that we want to work with for this function. And to start with, we want to find the vertex first. To find the vertex, we still want to use the point and go to extremum and choose this particular parabola over here, and we can see the vertex is this coordinate, and I'm going to pause and record this coordinate or the coordinates for this vertex first on the worksheet. Once you have the point recorded, then we again want to talk about the axis of symmetry, and for the axis of symmetry it's still going to be the vertical line that goes through the vertex, so it should share the x value as a vertex. So I'm going to type in x equals 3.13, and that should be a vertical line that goes through the vertex, and that's going to be our axis of symmetry. And let's go ahead and write it down. Axis of symmetry is x equals 3.13. They both share the same x value. And you can also call it p equals 3.13, right, if you want to be exact with the independent variable. And if we want to interpret these values, we want to say that the first coordinate represents the price for a cup of coffee. So we can say when the price of a cup of coffee is set to be $3.13, the revenue, which is the y-coordinate corresponding to that point, is going to be $1,171.88. And if you think about what the axis of symmetry is telling us, or the vertex is telling us, we can say this is going to be the maximum revenue. For our scenario. And before that or after this, we won't be able to reach that high of a revenue. If you price it higher, you'll actually start taking in less money just because you won't be able to sell as much coffee. And now if we want to look at part C, we want to determine the y-intercept and its mirror point and interpret in the context of a scenario. So looking back to it, we want to find the y-intercept, so we can use the function in GeoGebra that helps us find the intersect. So I'm going to select the parabola and the y-axis because it's a y-intercept, and you'll see this is a point B, which is 0, 0. And this is not a particular coincidence, because if we think about the algebraic meaning of the y-intercept, we would have plugged 0 into P, and we would have found that r of 0 is equal to 0 over here. So we can say when P equals 0, r of 0 is equal to 0. So therefore, we get the y-intercept in this case is 0, 0. And we can say for that particular point, that tells us when you're selling when the price of a cup of coffee is $0, your revenue would be $0. And it makes sense, right, in our scenario. It sounds a little trivial and obvious, but if you think about what this represents, it's consistent with our description of what's happening. And think about the mirror point of this. Might be a little bit more interesting. And if we want to look for the mirror point for this 0, 0, the intercept. We can again use the reflect about line function, and we can do the point, then the axis of symmetry, and it gives us b prime, which is 6.26 comma 0. And I'm going to go ahead and record that. That's a mirror point. And we see that for both points, the revenue is 0. And for the mirror point, it actually tells me when the price is set to be $6.26, the revenue will again be $0. And what happens in that scenario is essentially the cup of coffee is too expensive to be sold in this coffee shop in our given scenario. Therefore, there won't be any money brought in because no one would buy anything. So we can say the revenue is $0 total when the price is set at these two price points. And $6.26. So that's what these 2 points are telling us in this context. And next, if we want to find the x-intercepts and interpret them in the context, I'm going to go back to the graph. And for the x-intercept, we can actually see that that's where the y value or the function value is equal to 0. This is exactly what we found in the previous problem, where we found the y-intercept and its mirror point. These are actually indeed the x-intercepts we have. That's because my point 0, 0, it's not only a y-intercept, it's also an x-intercept. So we actually already found the answers for this problem using what we did in part C. So we can say that the x-intercepts are just the same as a y-intercept and some mirror point. So this is the same as answers in C, and the two x-intercepts, or in this case you can call them p-intercepts, are going to be 0, 0 and 6.26 comma 0. And they tell us when the revenue will be $0 over here. And you can also think about when we're looking at the y-intercept, we're more focused on the idea that when the price is 0, the revenue will be $0. And for the x-intercept, we're more focused on the starting point being the revenue being 0 when things happen, when the price is $0 or $6.26 per cup of coffee. With this in mind, we can think about some specific questions we can answer in our model. For example, what will be the average revenue per day if the price point of a cup of coffee is $2.75? So in this scenario, we would know that P is equal to 2.75, meaning our independent variable is 2.75. Going back to the function graph, I'm going to again hide a bunch of information because we don't need them anymore, and I want the price to be 2.75. So that should be where my price is set at, and wherever they intersect should be where I would get the corresponding revenue. And if we look at it, when we have 2.75 being the input, we have 1,155 being the output on the graph. And with this, we can say that the revenue, the average revenue per day, is $1,155 per day on average when the price is set at $2.75. That's how we can answer this question. And lastly, we want to think about at what price point would the coffee shop be able to get an average revenue of $1,170 if that's our goal for whatever financial goal we have. We really have the scenario of y equals the output being $1,170. And you can see it happens on the very tip of what we have or not quite the very tip, but it's very high up towards the vertex over here. And as we have this, we can again use the intersect function to find where they intersect over here on the 2 points, D and E. And they both have the revenue being 1,170. I'm going to go ahead and record these 2 points. And I believe these are the points we have, 3.25. These are the 2 points we have. With this, we can say that when you price a cup of coffee at these 2 prices, you will get the same amount of revenue. Because if you set it to be cheaper, you'll be able to sell more. As it becomes more expensive, you'll sell less. And the overall total ends up being the same based on our model. So we can say when the price for a cup of coffee is set at $3 or $3.25, the total revenue is going to be our goal, $1,170 as the result. And that's how we can use GeoGebra to help us graph the function and use all the little different functions we have in the software to answer all these questions without going through the algebra too much. And the nice thing about this is we can have messy numbers to work with, and it easily gives us the answer through a pretty quick 1 or 2 step process in order to get the answer and help us solve the problems.